All right, welcome to Unit 5, Linear Equations. This unit is all about lines and how we work with them. So we're going to start by looking at triangles. So here we have a right triangle, and we're going to label its parts. It says label the hypotenuse, right angle, vertex, height, and base of the right triangle given below. So we have a right angle in the corner, so this is our vertex, or our right angle vertex. And then we have our height, which would be our up and down. Our base would be our horizontal, and then our hypotenuse is across from our right angle, and it's the slopey part, or So similar triangles will have corresponding sides that are proportional, and you can verify similarity of right triangles by finding the ratio of their corresponding heights to their bases. So we're going to be looking for ratios. And a ratio that describes how steep a line is called slope. One way we can find slope is by drawing the right triangle using the line that we're looking at as the hypotenuse of a triangle. Okay, so for example 1, it says draw a right triangle using each large dot as the right angle vertex and the line as the hypotenuse. Then find the slope of the line by writing a ratio of each triangle's height over its base. We always put the vertical length over the horizontal length. Okay, so I'm just going to randomly pick some of these. So from that big dot down to my line, big dot over to my line, I'm going to count how tall it is, 1, 2, 3, 4, and how long it is, 1, 2, 3, 4. So my purple triangle has a vertical length of 4, a horizontal length of 4, and that simplifies to 1. Now if I take and go from this, my blue one that I just drew is 1, 2, 3, 4, 5, 6, 7 high, and 1, 2, 3, 4, 5, 6, 7 along the horizontal. So vertical over horizontal would be 7 over 7, which is 1. Let's pick another one. So this vertical is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 for the horizontal. So 5 over 5 is 1. Oh, it looks like my graph didn't go down long enough. Whoops. And we'll just pretend it did. We'll just make that go a little longer. We'll add some grid lines here. Probably about like that. That's pretty enough. Sorry about that. So if we go down to our line here, over to our line, 1, 2, 3, 4, and 4. So 4 over 4, which is also 1. So we would expect 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4, 5, 6, 7, 8. So 8 over 8, which is also 1. So all those fractions reduced. So we had some bigger triangles, some smaller triangles, but the ratios of our vertical length to our horizontal length always ended up being equal. So page 2 says draw the right triangle from each dot, and we're going to do the ratios again. Okay, so here over to there. So this would be a vertical of 1 and a horizontal of 2. That simplifies, or is simplified. Pick another one. Vertical of 1, horizontal of 2. Okay, this one we have a vertical of 3, a horizontal of 1, 2, 3, 4, 5, 6. And when we reduce that fraction, we get 1/2. 1, 2, 3 and a half. And 1, 2, 3, 4, 5, 6, 7. Well, 3 and a half is half of 7, so that also is 1/2. Usually we would do it to a whole number. That wasn't the best line to choose from. Next one, 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6, 7, 8. So 4 over 8 is 1/2. So I alluded to this a little bit a second ago. It says, would we get the same answer if we drew the triangle below? Well, maybe. Let's see what happens. If I were to pick a point down here, and I did this, my vertical here is 2, my horizontal is 4, so that would still be 2 over 4, which is 1/2. So yes, it doesn't matter if you do it above or below, and it doesn't necessarily matter how far away that vertex angle is from the line. We're going to look for prettier points where it's going to hit the line at whole numbers and those sorts of things, so we can be strategic about it, but truly it does not matter. Okay, and our next one, it says draw a right triangle slope using same instructions. Okay, so here we go. 1, 2, 3, 1, 2. So our vertical was 3, our horizontal was 2, and we can leave as an improper fraction. 3/2 is great. Next one, 3, 6 over 4. That reduces to 3/2. 3, 6, 9 over 2, 4, 6. So 9 over 6, which is also 3/2. Let's see, 3, 6 over 4, which is 3/2, and 3, 6, 9 over 2, 4, 6, which is 3/2. So again, does it matter where the right angle corner of the triangle is? Kind of. Okay, we want triangles that meet the line at whole numbers. Okay, it's going to make counting easier. Now it says, will the slope change depending on where the point is in relationship to the line? And the answer is no. The ratios will reduce to the same thing every time. Okay? So it says the slopes we have found in the examples above help describe how steep the lines are. And then on your assignment, you're going to be explaining kind of how you can tell by looking at the line or what those numbers themselves use, how we can talk about that steepness as a quantity, as a number. So good luck on your assignment.